So far, we were discussing IP multicast. Okay, we discussed IGMP, we discussed PIM, different deployment models with PIM. Now, PIM will stay a little bit at the edge. So we are going to discuss one of the most common multicast use case. So imagine now there is a customer at the edge using PIM, but they want to send between their sites, let's say headquarter and the spoke sites, the PIM control and PIM data plane messages between the sites. But in between, there is a layer 3 VPN. Okay. Why, Orhan, you say layer 3 VPN? Because with the layer 2 VPNs, we will not have this issue that service provider, the mid-red network, WAN network, service provider network, let's say, with the MPLS L2 VPNs or any type of L2 VPNs like TDM, ATM, previous days, frame relay. So they are layer 2 VPNs. So service provider would be transparent. So PIM messages underlay layer 2. PIM is layer 3 protocol. Service provider will not interact. But when service provider provides layer 3 VPN, like what we will see in RFC 4364, this is the updated version of 2547, by the way. When the service provider gives this service, this is, by the way, for the unicast VPN, so MPLS layer 3 VPN for the IPv4 unicast service, this one by default. Okay, so when the customer wants to send their PIM, so multicast control and data plane messages between their sites, then multicast support is necessary inside this layer 3 VPN. Multicast over layer 3 VPN will be our another topic now in the multicast training. So multicast VPNs, very huge topic. So we will start, we will learn also many other things like what we spend, maybe even more time now with the multicast VPNs we will spend. But those previous PIM knowledge, of course, it is good. We will time to time use this knowledge also inside the multicast VPNs. So far, this layer 3 VPN normally provides by default IPv4 unicast, but customer might be looking for the multicast support as well inside this MPLS layer 3 VPN network, but it is for a unicast. So in addition to unicast, service provider needs to also support how to tunnel, how to send these multicast messages of the customer inside their provider network. That is the whole idea of these multicast VPNs. And it was specified in RFC 6513. Actually, lots of the talk of this training in the multicast VPNs already in this RFC. Of course, sometimes understanding may not be that easy. And also, most of the example now, we will be covering from the Cisco point of view. So this training also will be very helpful for the CCIE trainings. In fact, we are using also the same videos for the CCIE Enterprise, CCIE Service Providers, etc. Those people, CCD as well, these people. And obviously, the understanding overall idea will be helpful for other vendors' exam certification and also for real life overall. Okay? So in BGP MPLS IPVPN, when I say any more 4364, I am just telling that one, or L3 VPN when I say layer 3 VPN, I am trying to tell you this RFC, so providing IPv4 unicast service by default. Unicast routing of VPN packets is achieved without the need to keep any per VPN state in the core of the SP's network. So if we remember that unicast MPLS layer 3 VPN, what was the elements? PE device, P devices, and another PE device. So ingress PE, egress PE, and P devices. So lots of terminology normally we use there. If there is traffic engineering, head end and tail end, we say. Also common MPLS terminology, those edge devices from the labeling point of view, LER, label edge routers, and mid routers, P routers, LSR, label switching routers. So, but those P routers, very common terminology, and throughout this MVPN discussion, I will use also PPP. Lots of time you will hear this P term from me. So in the unicast VPN case, those P devices, mid routers I mean, they will not keep any customer prefix, VPN prefix information or VPN label information. So they don't even need to have BGP at all. We don't run BGP on those routers. In multicast, things are different. In unicast, they don't need to keep any unicast information for the VPN label, for the VPN prefix of the customer, etc. In multicast, we will push the information to those P devices as well. How much information depends on which multicast VPN model we are using. So some of those models we will push more information to P device, some models less information. So we will talk about trade-off called scalability versus optimality. We will see this how much state we will push onto P device. It is one consideration, obviously, but there are many others we will go through and learn. But so far, for the unicast case, we were hiding the VPN label and VPN prefix of the customer from the P routers, from the core routers. Edge router still know, of course. Edge router knows the VPN label and meaning of the VPN label, what is that VPN label, towards which VRF I should use, etc. And also VPN prefix of the customer, obviously. So because they were making those prefixes VPN prefix, when they receive the customer IP prefix by adding route distinguisher, we are making IP plus RD VPN prefix. But here, we will not hide the those multicast VPN information from the P device. Routing information from particular VPN is maintained only by the PE routers that is basically connected to that customer VPN with the unicast one again. With the multicast, obviously not only PE as well will keep the state. Will know the multicast information, not only PE routers as well, end to end. Still, I am going through the unicast case. Unicast, and then what's happening with the multicast also, I am adding that. Customer data travels through the PE routers in the tunnels, in tunnels from one PE to another PE. So to support the VPN service, the PE routers only need to have routes to the PE routers. What is here I am telling? PE's devices functionality is to provide reachability between the PE devices, guys. Why we use P? Of course, we use P normally for scalability in those networks. So you can otherwise remove the P device and PEs can be directly connected, and we call it one-hop LSP. But scalability is the reason when you use it, the functionality of that, I mean, PEs when you connect directly, they will know each other, you will assign IP, they can talk with each other. But now PEs are apart, and in the middle you put the P device. So how those PEs will reach each other? Either that P device needs to be at layer 2 at all, or if it's layer 3, it needs to be routing between those PE devices. So those PEs still need to reach each other end to end. P's function is basically provide that reachability between the PEs in unicast case, not carrying the customer VPN information. VPN is basically in a label stack is hidden behind that transport label, behind that tunnel label, either via LDP it was, RSVP, segment routing, or BGP plus label, RFC 3107. Okay? Another thing is, still we are going through the unicast and what's happening with multicast. With the unicast again, 4364, the PE to PE routing is optimal, but the amount of associated state in the P routers depends only on the number of PEs, not the number of VPNs. What we are saying, P routers doesn't have to keep the VPN information, just the P routers, PE router reachability. So here, P's function, P's number of state on the P device doesn't grow with the number of VPNs. Doesn't matter. If I have one VPN, if I have 100, if I have 10,000, from P device point of view, control plane doesn't care basically the number of VPN. Okay? State is not related with the VPN on the P routers with the RFC 4364, which means unicast MPLS L3 VPNs. I was telling you this scalability versus optimality trade-off. Let's understand this, very important. this importance of this, when we learn all those MVPN models, those different core tree types and all those things, later on we will say there will be new architecture. Now there is a new architecture called beer, and now we are also winning from both scalability and optimality point of view. Obviously there is also trade-off there, but from many aspects, maybe better multicast architecture. Okay, but let's go there slowly. What is this trade-off? So far what I was telling you, in the unicast case, P router doesn't keep the VPN state, but in multicast we will push. So how much state we should push? Per VPN, or can we aggregate those VPNs and aggregated states on the P routers? So if I push more information, not an exception, in design what we do, more information mean optimal routing, but scalability is bad, like in SSM case. So if you create separate tree, we will talk about those trees now. So if we create separate tree per VPN, maybe optimal routing it can push, it can bring us, but scalability might be a concern. Okay, less information, good for the scalability, but bad for the optimality. Here is the same idea. In order to provide optimal multicast routing for a particular multicast flow, the P routers through which that flow travels have to hold state information that is specific to that flow. So that flow needs to be told to that P routers. This is multicast. If we hide it, so far in IP multicast, each and every router were knowing that, right? And if we introduce now MPLS, so we are talking now MPLS VPNs, right? Environment is MPLS now. In addition to IP, we have MPLS, guys, right? If you didn't realize, now you realize multicast VPNs, MPLS network we have, but that MPLS network, normally P routers, we were not putting any VPN customer IPv4 was becoming VPN prefix, and we were hiding. They didn't know those VPN prefix, etc. We were hiding them. But here, we don't. In IP multicast, we don't. So all those PIM, ASM, SSM binders so far we have been talking, I was not telling you PEP, etc. Each and every router, we were enabling multicast, and all those routers, if there is an S, G, they know S, G. If there is star, G, they know star, G. Here, MPLS, okay, they will still know S, G's, star, G's, etc. Those multicast informations. But those flows can be aggregated. If individual flow, maybe optimal, but not scalable. The multicast flow is identify what is the flow, so some information in the packet. So multicast flow, source and group tuple, where source is the IP address of the multicast sender and the source we have been using interchangeably, IP address, unicast obviously. And the group is the IP multicast group address of the destination. Scalability would be poor if the amount of state in the P routers were proportional to the number of multicast flows in the VPNs. What we are saying, more flow, less scalable. Why in the first place MPLS layer 3 VPN for unicast was scalable compared to IP destination-based routing? Because we were hiding the VPN label, we were hiding the VPN prefix from the P routers, from the mid routers, those LSRs. Now we will push with the multicast, we will push those customer states to the P routers. So more state, maybe more optimal routing, but less scalable. It's all about those, we will see lots of profiles, basically those profiles based on scalability and optimality trade-off. Okay? And encapsulation also. Would you want to use IP or, GRE in this case, or MPLS encapsulation? So scalability would be poor if I would push more flow information on the P device. Those PE anyway they have to keep. In unicast also, PE device, they keep those state information. In unicast VPNs, PE device, edge device needs to keep the flow, those IP flows, and they make them VPN, and VPN is tunnel inside the transport label, blah, blah. Therefore, when supporting multicast service for MPLS IP VPNs, MPLS Layer 3 VPNs, the optimality of the multicast routing must be traded off against the scalability of the P routers. You want more optimal? Put more flow. So same thing with the SSM. More optimal routing, put escamages, but scalability will decrease. Resource usage will increase. So more money you will spend. Okay. So now slowly we are going to understand what are the requirements for multicast VPN, so on and so forth. What I told you in the IP multicast case when we discussed PIM, so unicast routing has to work. Same thing here. Unicast VPN has to work for multicast VPNs. Okay? Because again, we will rely on the RPF and multicast relies on unicast reachability. It has to be there. Let's agree on that. So we are talking VPN, L3 VPNs, and that L3 VPNs for IP prefixes already working, and then on top of that, multicast relies on that reachability. Okay. Now a little bit about entry. After we talk multicast and trade-off with the multicast VPN compared to unicast VPN, the difference is very, I think, obvious now. We were hiding all the state information from the P device. Now we need to push onto the P device, because expectation is not the ingress router, the ingress PE router, but mid routers, those P routers, to do the replication. There is a model we call IR, ingress replication. Ingress PEs will do multicast replication. In that model, those P routers, you don't need to run multicast at all. You can hide the lots of state information. So great. So, but trade-off. So in that case, lots of pressure on that ingress router you put. More resource consumption on the ingress router. In fact, overall network, of course, the bandwidth usage also will increase, because not the mid routers is doing the replication. So in that case, in the ingress replication case, what we will do, ingress router would normally send, so ingress replication per receiver, separate copy, but normally native multicast, which we will discuss, when we put the state information in the P device now has the state, multicast flow. So ingress router will send only single copy of that content, and it will replicate. So overall, bandwidth usage will decrease obviously with this native, but you put more state in the P router, or you want to increase the bandwidth usage overall in the network. So ingress replication might be seen good alternative for the multicast. So because customer multicast traffic still will be tunneled over the unicast LSPs, you don't need to create multi-point LSPs, etc. We will see. So just whatever you use today for the layer 3 VPN for unicast, you can use that one. Or we will introduce the state, so multicast information to the P routers, let the P router do this multicast replication. So this is different than unicast approach, guys. Unicast VPN, P routers were not involved in the VPN. They were just providing the communication between the PE device. So they were totally infrastructure device of the service provider. But with the multicast, they are now the part of the solution of this customer VPN. They need to know the flow information. And more flow information, more optimal routing, but less scalable. Okay? So architecturally, these multicast VPNs, guys, when we talk about the multicast VPN now, layer 3 MPLS VPN, and carrying the customer multicast traffic inside this multicast VPN, we have two approaches. Classical MVPN, classical. So multicast VPN, MVPN, I will use interchangeably. That M is multicast. So I will use interchangeably, don't forget this. classical MVPN and NG MVPN. What is this? With the classical approach, it's also known as the Rosen GRE approach, PIM GRE approach. So we used to have basically PIM in the provider network, customer always PIM. So PE to CE protocol in the IP unicast case can be OSPF, ISAS, EIGRP, BGP static routing or load. In multicast case, it is PIM, protocol independent multicast. That's why we learned that. So PIM is the PEC protocol, but in the classical MVPN, PIM also inside the provider network. Okay, but in the classical MVPN, interestingly, MPLS is used for the unicast, but how you are tunneling the multicast traffic inside the GRE, not the MPLS encapsulation, GRE encapsulation. So you can think as a on the single physical network, two logical network, one of them MPLS, another is GRE, unicast is carried inside MPLS, and multicast inside the GRE with this classical approach. And very highly, very commonly deployed approach, guys. It was the first approach. Okay, and actually the inventor of this protocol, almost the inventor of any other NG MVPN protocols, including not NG MVPN, also beer protocol, BT-next execute replication, Eric Rosendraft. So, I mean, same thing you will see Yakov Rektor, right? Almost every BGP and enhancement with the BGP, you will see the Yakov's name. So he's the BGP inventor, and for the extensions, Eric is not different in this case. Also, you will see most of the BGP MPLS-based BGP VPNs create compel as well. Anyway, with the classical approach, then we have like a totally logical different networks. So PIM inside the provider as well, not only customer side, inside the provider as well. And also encapsulation-wise GRE, not the MPLS. Good. What's happening? Classical MVPN version, PIM GRE is based on the draft Rosen and requires PIM in the core of the provider network to able to support MVPN, correct? This requirement introduces new protocols, PIM and encapsulation mechanism MGR in the control and data plane. So normally we don't have, of course, PIM inside the layer 3 VPNs. So inside the MPLS layer 3 VPN, we talk about LDP, RSVP, segment routing for the transport label, and on top of that for L2, L3 VPN, targeted LDP, BGP, that's it actually. So these are the protocols. When it comes to multicast, with this classical approach, what we are seeing, PIM to carry the multicast traffic inside the provider network, but it was normally, it should be in the customer side. But now in the provider side as well. The idea is what? Maybe, I mean, let's think about it. Let's not blame or let's not just say, it's the old approach, not good. No. PIM already at the customer side. PIM is very, people are familiar, very complex. We will see why. But soft state, etc. But it is people are familiar with. Now you will teach many other things to people. They will be familiar. Operation faults needs to understood, troubleshoot, and all those things. Can be done, yes. But imagine starting from customer. Maybe, by the way, this entire solution is, I mean, MPLS VPN network, layer 3 VPN network belongs to same entity, same company. Let's say that airport, which we were also talking in the multicast many times. So airport, layer 3 VPN is very common in the airport networks, right? So lots of segmentation is required. So on that case, so you can use any of this approach which we will learn. Classical VPNs with the PIM and GRE or NGM VPNs with the transport LSPs, so basically MPLS and then BGP, etc. again are familiar unicast approaches. With the NGM VPN, we will continue. So classical approach basically is we continue whatever we use for the customer side, PIM, in the provider side also PIM. So unified PIM. We have unified MPLS, seamless PIM. Okay? I am maybe laughing, but it's not a joke. So the people might think in this way. But this is entire enterprise solution, and MPLS L3 VPN is in the enterprise network. So they are already familiar with PIM for the multicast, how it works, etc. They know very well. So let them continue to use basically PIM inside this MPLS network as well. So in the customer side, PIM ASM, let's say, inside the service provider side, also another PIM ASM domain. So we will have, let's say, customer RP, then ASM RP, rendezvous point, and also we have provider RP. Correct. PP, because so here this PIM domain of the SP will be different than customer PIM domain. So far, classical MVPN, when we say, this is, I mean, definition. The Rosen GRE, if I say, you will understand PIM inside the provider network and GRE tunnel, basically, instead of label switch path for the multicast, okay? Label switch path in that case used for only unicast traffic, and GRE tunnel is for the multicast traffic. So control plane in the provider network for the multicast VPN is PIM. Data plane inside the provider network for the multicast traffic is GRE. So control plane PIM, data plane GRE. And we will discuss also this model when we go through profiles, etc. more and more. So NG MVPN model, so next generation MVPN is called, by the way. NG MVPN, many resources basically mentioned in this way. Uses the same protocol used in the MPLS L3 VPN unicast service, RFC 2547, 4364, updated one. So BGP and MPLS protocols. What do we mean on MPLS protocol? So LDP, RSVP we were saying, and segment routing, all of them also here. So in that case, just we will have, instead of having point-to-point LSP, because unicast is point-to-point, obviously. Label switch path is point-to-point. Noran, I heard that LDP LSPs are not point-to-point, multi-point-to-point. Correct. But let's not go into detail. Let's learn that point-to-point. RSVP, point-to-point also. Segment routing, point-to-point. Controller-based segment routing is different story. So transport, still same protocol like what we use for the unicast layer 3 VPN. Multicast layer 3 VPN, unicast layer 3 VPN, with the next generation MVPNs, they are using the same protocols. Service also, so in that case, service, from the service what we are expecting, that customer multicast traffic will be sent between the PEs. That might be also same BGP, or it can be also classical PIM. Okay, we will also talk about them. With some extension to the control and data plane protocol is necessary to be able to support multicast traffic. Correct. So those LDP, now we will call it MLDP, multi-point label distribution protocol. RSVP, still RSVP obviously, but point-to-multipoint RSVP. Normally RSVP is point-to-point protocol. Point-to-point LSP we create, okay? Always. Now in the multicast case, point-to-multipoint LSP we will create. Okay. So before we deep dive those, protocols for the transport, protocols for the service, and lots of protocols, let's first understand again these trees. So in IP, what we did for the IP multicast discussion, we first understood what is shortest path tree, what is shared tree. We call them MDT, multicast distribution trees, multicast traffic, how it's distributed. Here, I will do the same approach. So in IP multicast, I did shortest path tree, shared tree, and then different PIM deployment models. PIM SSM, ASM, BIDR. Here, also, I will first talk about the MDTs. So here, multicast VPN, names are different. Of course, I mean, we need to make them fancy. So there is no shortest path or shared tree, etc. now. We will see different type of multicast distribution trees, default MDTs, etc. After those MDTs discussion, we will bind the information which we will see later. Let's say MLDP. Okay, MLDP can do this kind of trees. RSVP can do this kind of trees, etc. We will combine all this knowledge. Okay, I will first start from the distribution trees first. So we will first look at the different type of MDTs, which mean underlay transport. MDT, multicast distribution tree, transport network first, and then service, transport service. Like MPLS normally when I teach also, first transport, the tunnel I mean, LSP I mean, between the PE devices, and then on top of that, what I am signaling, what I am teaching between those edge points. Okay. So basically how this service can be mapped, those overlay, underlay concept. Transport is underlay, service is overlay. Underlay transport network. After that, all the required protocols and the options for the multicast VPN, I will explain. NDTs, so multicast distribution trees, can be created by any core tree protocols. I will go through each one of them separately. Core tree protocols, PIM, and PIM also here. A classical MVPN. I was just telling you, classical MVPN, that PIM function is a control plane to create us the transport, which means MDT. MDT is transport, guys. Multicast distribution tree mean transport. In IP, I didn't use this term transport, but it's providing us a transport, which means when the ingress PE device receives the traffic, who are the edge points? Maybe you specify as a statically or dynamically you learn who are the edges, who are the receivers, and now traffic from ingress to the egress will be pushed. Maybe one copy and mid routers will replicate, etc. Yes, but those should be known. Who are the receivers? So MDTs, this transport can be created by PIM, classical MVPN, or with the next generation was MLDP or RSVP, or we will see ingress replication. This guy with this one, we don't need to introduce multicast in the MPLS network at all. So it is still unicast LSPs, but with these ones we will create point to multipoint with the point to multipoint LSPs with here, and with this one PIM we will create multipoint GRE tunnel, but multipoint again, MGRE tunnel. So these are for the multipoint things, multipoint control planes. This guy still unicast per each and every receiver, but with this one ingress application you don't need to introduce multicast in the P network, in the core network, in the MPLS network. Okay, we will see those. So the next discussion, we will start the multicast distribution tree, different type of trees we will learn, and some terminology will come from the IETF side, from the Cisco side, etc. But let's start with the next video.